Did you answer the questions? Who needs more time? I will give you 1 more minute for some of you. Please come to class on time. Okay. Let's start to solve these questions. The first question, as I'm looking for, 45%. Oh, first question, almost half of the class answered correct. And then also second one, 50%. Half of the class study, half of the class needs to study more. Okay, guys? First question, when the rigid body undergoes a translational motion due to external forces, the translational equation of the motion can be expressed for which point? If you remember, for a rigid body, we used the Newton's second law. This is the general form of the Newton's second law. Or we can develop and extend this one for a rigid body. That, if you know, and also just the rigid body consists of several particles. You learn about to use this equation of the motion for one particle. Also, if we want to use this one for a rigid body, instead of that adding and use this equation for each of the particle, we can put and consider one point called center of the mass. Instead of that adding those forces for each of the particles, adding the sum of the particles' mass, and we can write this equation for center of the mass. Instead of the one point, just we consider only for center of the mass. And we can write this one along the x or along the y direction. As you saw, I used this equation to solve examples on previous lecture. First question, this one, B. Second one, the rotational equation of the motion about the mass center of the rigid body indicates that the sum of the moments due to external loads equals to, for the second question, just give you some tips that how you find the answer. For example, you do not know about this. Consider that you're new and also you were in this section and also you're doubting about the options. For example, I'm asking about the moment. Okay, this option. What is this? MAG. What is the type of this one? Force. We are now looking for force. Cancel this. Also, this one. It's a summation of something you do not know about this something, for example. How about this one's the force? Cancel this one. And also, most of the time, this one is the kind of correct answer. None of that one. Means that that's the correct. If you do not know. I will give you the tip how to solve. But let's solve this one. How to solve this? If you remember, I used this equation. Ri multiplied by summation of the force along the I. This is the moment of external forces. Okay? Plus summation of the external moments. This one is equal to R bar, means that this is the moment of inertial force. This one is measured from the center of the mass. Also plus Ig of, this is the because of the torsion or the torque, because of the rotation. Now for this problem, the rotational about the mass center. About the mass center. If it's about the mass center, this one is 0. Because there is no distance. Just we are looking for, if this is the MAG, we want to find the moment about the G. The distance for this one is 0. This term is 0. Left-hand side is a summation of the moment of external load moments equal to Ig of A. It's a correct answer. Got it? Any questions? Okay. No questions? Now, solve more examples for you. The door, please pay attention. From those examples I will solve today, the quiz will be similar question, similar procedure. You need to use, if you just follow, you can answer the quiz easily and get a good grade. The door has a weight of 200 pounds. This is the weight of the door, not the mass of the door. And the center of the gravity, it is given. We want to know that how far the door moves in 2 seconds. For example, if this person push this force, that the force magnitude, the magnitude of force, it is given how much this door moves. For example, this is the movement of this door. Also, find the vertical reactions. These are the reactions at A and B. We are looking for these reactions. I will give you 1 or 2 minutes. Just think about this problem. If you want to write it also, you can write it. Then I will start to solve. Okay, let's solve. The weight of the door, it is given 200 pounds. How can I find the mass of the door? How? Divide by 32.2. Make sure in the kind of when you solve a problem, check the units. Still, some of you do not check the units in the problems you want to solve. I know you know how to solve it, but please, please, please check that this is the weight, this is the mass, this is a US unit, or this is a SI unit. That's the easy part. Then it takes 2 seconds. And we are looking for to find how far. I'm looking for to find this distance or movement of the door. If I apply force of 30 pounds, also I am looking for to find the reactions. These are the reactions at A and the B. We are looking for to find the reactions at A and B. Now, to solve this problem, let me just make another one. First, for this one, is moving along the x. This is the x direction. This is the y direction. Also, for this, I will draw a free body diagram on this figure and also a kinetic diagram on this figure. To draw the free body diagram, I need to show the external forces. I already showed those reaction forces, as you can see here, this reaction force and this reaction force at this roller A and roller B. Also, there is a one external force. It's the weight of the door. And we have this force, 30 pounds. There is no friction force because already the coefficient of the friction is not given. If you saw the coefficient of the friction is given, consider the friction force. If not, do not consider it. Also, I want to draw kinetic force, kinetic diagram. How? On center of the mass, I will draw this inertia force, MAGX. And one, it is MAGY. These are two inertia forces along the x and along the y direction. These are forces. Do not draw those ones on free body diagram. These are different. Also, I add one more along the G. It is called IG alpha. This torque, or this one, is because of the rotation. But I can simplify those ones. The reason I just put those ones for you to know and also review what type of elements you need to just draw on kinetic diagram. For this door, how much is the acceleration of the G along the Y? 0. Does this door rotate? No. 0. That's it. You draw this, you already just solved 20% of this question. Then, first, we want to use the equation of the motion. What equation of the motion? Look, if you refer to the week 11, I shared the equation sheet. I will use these equations. I want to capture it, bring it for you. I will use these 3 equations. this tree one. Okay, I want to use this tree. Now, for the first one, if I use this one, summation of the forces along the x equal to MEGX. The forces that along the x is only F. There is no other forces along the x. I will write this one, F equal to MEGX. Or we have the force, 30 pounds. We have the mass, 200 divided by 32.2 multiplied by AGX. From this, you can find the acceleration of the door. If you calculate this one, this will be equal to 4.83 foot per second square. This is the first equation. The next one is this one. Summation of the forces along the y equal to MAGY. This is the force along the y, mass multiplied by acceleration of the center of the mass about the y direction. Left hand side, look at the free body diagram. Right hand side, look at this one. Can move to next slide. Still some of the right. Can move to next slide. Still you have time. Just I need to capture the free body diagram and bring those ones to the next slide that you can see how I found those ones. Then, next this one. Summation of the force along the y equal to mass acceleration of the g along the y direction. Or we have these forces along the y direction. There's 3-1 that I just show you in a circle. Normal force of the A plus normal force of the B minus weight equal to, you know this one also 0. Why? Look at the kinetic diagram. Is 0. Normal force of the A plus normal force of the B equal to weight. What's the weight of this one? 200 pounds. This is the second equation. Then, what is the third one? Is this one. I do not want to repeat, just this equation. Okay. Same as this, you will see on the equation sheet. You can use this equation about the center of the mass, G, or you can use this equation about any point. These are all equal. For example, if you use this one about the G, still you have two unknown. Why? Normal force of the A and the B, they have moment about the G. However, you can do a kind of smart selection. Why? If you find the moment about one of these points, A or B, you already eliminate one of the unknown. Means that if I use this one, look, what is this equation? This is the moment of all forces about the point P, or I can write summation of the moment about the point A. Instead of P, I use A. Also here is A. This adding different inertial forces equal to summation of the moment of inertial forces about the point A. How to solve this one? I will show you. For this one, I will make a table. I will list the forces, the moments. What are the forces? Just I list them. Normal force of A, normal force of B, weight, and the force of F. These are all forces I have. This, and this one. There is no force. Do not bring these forces into this table. This one is for this. Do not bring the inertial forces to this table. Now, what is the moment of the NA about A? 0. Easy one. What is the moment of normal force of the B? Yes. How much is it? Times 12. MB times 12. MB multiplied by this distance, 6 plus 6. I write this one look like this, that you know that how I found the 12. Also, this one's positive. This look like this. R multiplied by force. If you do this one, look like this. You are opening the cap of this. Look. If I apply this is distance. This is the force. I open this one. This is something positive. If I apply this one in this direction, I am closing the cap. This is negative. Got it? If you want to just consider the close of the cap as a positive, it will be different story. Now, also the weight, there's a weight about the point A. It has a distance of 6 foot. Weight multiplied by 6. This is negative. Why? It's closing. Just this is how I remember it from 20 years ago. Also, the force of F. Oh, sorry. The force of F about the point A is force multiplied by the vertical distance. How much is the distance of F? Look, this is the F direction. You need to find the vertical distance from the point A. What is the vertical distance? Is this one. How much is this one? Total is 12. This one is 3. This will be 9. This will be F multiplied by 9. And this is positive. Now, if I sum all of this, if I sum all of this ones, this will be summation of the MA. It is NB multiplied by 12 minus weight multiplied by 6 plus force multiplied by 9. This is this. When you are finding the moment, do not look at the kinetic diagram. Consider that your right eye doesn't work at that moment. Left by left, right by right. The reason I just didn't put because this one is too large. Now, next one is the summation of the moment of inertial force. Look, I make another table. No. Inertial force, moment. What are the inertial force? Look at this one. I list all of them. MAGX, MAGY, and the moment, because this one is the moment. IG of. Now, this is already 0. The moment will be 0. This one doesn't rotate. Good. I like it. Also 0. The only moment I have, the moment of this inertial force. means that MEGX about the point A will be, this is the force, this is the distance. This distance, that is here to here is 5, this is 12, this distance will be 7. And what is the moment, look? R multiplied by F. You will open this one, or your thumb is outward of this plane, is positive. This will be MEGX multiplied by 7. Based on my experiences from my previous students, most of my students, they have struggled on this thing. I'm not sure why. I try to just make it kind of more simple, explain. This is the problem only. They know how to find the moments and those things. And the next issue they have, they confuse the inertial forces with these forces. They bring those ones to the left, mix them together. Do not mix them up. Left by left, right by right. Or here, just this one top, this is bottom. But for the next example, you'll see that it's side by side. Now, this if I use the highlighter, oh no. This one is this. That's it. Now, if you allow me, I can move to the next slide to just equal them and find the unknown. Can I move to the next slide? Any questions? Any confusion? Any unknown questions? No? Any questions? Can I move to the next slide? Yes. Now, from previous slide, I want to write. Hopefully, I remember it. Summation of the moment about the point A equal to summation of the moment of inertial forces about the point A. Now, normal force of the B, 12 minus weight multiplied by 6 plus force multiplied by 9 equal to MEGX multiplied by 7. What I have, I do not have normal force. But I have the weight 200. Force also, it is given in the problem 30. The mass, it is 200 divided by 32.2. The acceleration, I found it, given moment, 4.83. Multiply by 7. As you can see, there is one unknown, is normal force of the B. And if you calculated normal force of the B, it will be, let me cheat from my solution, it is 95 pounds. One answer. Also, from equation number 2, we found that normal force of the A plus normal force of the B equal to weight, or normal force of the A plus normal force of the B 95, weight is 200, normal force of the A will be 105 pounds. Second answer. Now, we want to know that how much the door moves. For example, if you saw that one, push this one, this door moves to the right. We want to know how much is this. Can somebody tell me how can I find this distance? How? How can I find the distance of this door, or how far this door moves? I do not have the solution of this one. Help me. How can I find this D? Yes. Kinematic equations, correct. If you look at this slide, we found the acceleration is a constant, 4.83. Now, you have them as a constant. Refer to the equation sheet I provided for you, and you have it. Then this is constant. You need to use one of this. Which one? This one. If I capture it, this, right, this, I bring it, you saw that where this equation is coming from, I use one of this one. Instead of SD, starting from rest, plus 1/2, acceleration is 4.83. It takes 2 seconds. Then from this one, you can find this one, 6.9.66 feet. This is the answer. Got it? Any questions? No questions? Yes? Can you go back to the first slide? Yes. What's your question, Diego?
Actually,
Where?
well, I think it was the second slide. I was just confused
Where?
4.83 came from.
Which one?
4.83. I think it was on the second slide.
4.3. Show. Oh, okay. From first part. This is I found from the acceleration.
Oh, okay. Yeah, because I just, I found it, yeah. I wasn't looking.
I found the acceleration when I just put the equation of the motion along the x direction. Other questions? Other questions? For the quiz, you have to just follow similar steps. Any question, guys? No questions? Okay. Let's move to the second example. There's a motorcycle shown below with a mass of 125 kilograms. Rider has a mass of 75 kilograms. We want to find the minimum coefficient of the friction between the wheels and the pavement. If the rider do a wheelie, the wheelie means that bring the front wheel to the air. For this condition, we want to know that how much is the coefficient of the friction for the rear tire with the pavement. Also, what is the acceleration needed to do this? Give you some time if you want to write. Okay, I start to solve. Yes. Hey, for this problem, the mass of motorcycle and rider it is given. I just write mass of R is a rider 75 kilograms. The mass of motorcycle it is 125 kilograms. What we are looking for? We are looking for to find coefficient of the friction. Also, how much the acceleration of this motorcycle if this person or this rider wants to do the wheelie. Have you ever tried this one? No, do not do it. It's dangerous. But the city that I came from, most of the young people in my city, they do this in the street. They like, even though with 2 person or 2 riders or 3 ones, it's so dangerous. Okay, now, for this one also, we neglect the mass of the wheels. Already we can consider the mass of the wheels and also the rotation of this ones. But this makes this problem a little bit complex. And also the front wheel is free to roll. There's no friction. So, first, this one, we will consider X and the Y direction, look like this. We will draw a free body diagram on this and the kinetic diagram on this. Now, draw a free body diagram. There are 2 weights. This is the weight of rider. This is the weight of the motorcycle. There are 2 normal force at B and at A. There are 2 frictional force at B and at the A directions. Now, for the condition that the motor or motorcycle do a wheelie, which parameters do you think that they are 0 for the wheelie? Yes.
NA and the friction on A.
Correct. If this one doing wheelie, the front wheel will be on the air. When it's on the air, this is 0. Also, because there is the front wheel also is free to roll, this one also will be 0. Now, for the kinetic diagram, I just draw these two one. I neglect other ones. There are two only inertial force. Is this one is the mass of the motorcycle, AGX, also mass of the rider, AGX. What's the point of this one? You will see that I consider same acceleration for the rider and the motorcycle. For this type of problem, when you want to write and also draw, might be this question comes to your mind that do they have different acceleration? No, they have same. All passengers that you are driving, they have same velocity, same acceleration, just based on the kind of the observer from the outside of the window. This is the kinetic diagram. Already, I just do not show this one along the Y, the rotation also. I neglect. There's no rotation. There's no this one. I do not draw those ones. Now, first step, use the equation of the motion. Look, sigma fx equal to magx. Left of this equation, look at this. Right of this equation, look at this. Left by left, right by right. The forces that we have along the x, we have this force only, the frictional force of the B. If you look at this is the only force along the x direction. There is no force along the x. We already have this one, but this one is 0. We have only this. Frictional force of the B equal to mass AGX. Or this one, it is equal to mu normal force of the B. And for this one, I consider this rider and the motorcycle as a one rigid body. And I put M as a summation of the mass of the rider and mass of the motorcycle. Now, if you just put whatever I have from this equation, we do not have mu. Normal force, mass of the motorcycle 125, mass of the rider 75, AGX. If you look at this equation, there are three unknowns. We are looking for the kinetic coefficient of the friction, normal force of the B, and also acceleration. We need more equations. The second equation, it is this one, 2. Summation of the force along the Y equal to M AGY. Forces along the Y direction, we have this, and this one, that this NA is 0, means that If I rewrite this one, normal force of A plus normal force of the B minus weight of the rider minus the weight of the motorcycle equal to 0. You will see that this one is 0. Now, also this one is 0. If you calculate normal force of the B minus this one, rider 75 multiplied by 9.81 minus weight of the motorcycle 125 multiplied 9.81 equal to 0. From this, if you calculate it, let me calculate. $1962 Newton. Now we have this. We need two more. We need one more equation to find this and this. Any question until now? Okay, move to the next step. Yes.
I promise I will give you a break in a short time. Just keep with me. You're gonna sleep.
Now, the last one. I am looking for to write the equation of the motion about point P. Which point do you select to find and also calculate this equation? If you were me, which point do you select? A, B, G1, G2. Yes. B. Other students. Yes. B. Do you agree? Is there any person that have different opinion? Yes. B is the kind of good choice or smart choice. Why? You already eliminate two unknowns. Make sure when you solve a problem, I like this way. This just to select or just solve less computational equations. Now, for this one, we will select the point B, means that summation of the moment about the B equal to summation of the inertial forces about the B. Left, look at this ones. Right, look this ones. Now, we have these forces, and these are the moments. I skip writing these two ones because they are 0. And also, we have this force, and this force. Normal force of the B, frictional force of the B, weight of rider, weight of the motorcycle. This is this, this is this, this is this, this is this. Normal force of the B and also this one will be 0. Why? Because I selected to find the moments about the B. What is the moment of the weight of the rider, or WR? What's the moment? This. Yes.
Negative WR times 0.4.
Negative WR, exactly. This one should be negative WR. This distance 0.4. Same for the weight of motorcycle minus W of the motorcycle. Then this distance plus this distance 0.4 plus 0.4. This is for the left of this equation, left hand side of this equation. For the right hand side, I make a table. This one, inertial moment, inertial force. Their moment. The initial forces I will look this one, left by left, right by right. Now, I have these two ones, MRAGX, M of the MAGY. Now, their moment are easy. Just I need to find this distance for the MRAGX and this distance for MMAGX. It will be M over rider AGX multiplied by the distance of 0.3 plus 0.6. Also for this one, M of the motorcycle AGX multiplied by 0.6. Or this one is equal to M of rider 75 multiplied by AGX multiplied by 0.9. This one is equal to 125 AGX multiplied by 0.6. Now, if I add all of these ones together, this is left hand side. Adding these ones together, this is the right hand side. If I want to write, this will be minus WR multiplied by 0.4 minus WM multiplied by 0.8 75 multiplied 0.9. This by this will be 67.5. 125 multiplied by 0.6. This by this also will be 75. Means that is equal to 67.5 AGX plus 75 AGX. From this equation, the only unknown we have is this one. If we calculate, because we have the rider weight and the weight of the motorcycle, we can find AGX as the acceleration will be 8.95 meter per second squared. Yes.
Why is it not a negative acceleration if our weights are, or the moment of our weights are both negative?
Why, if the acceleration is negative?
Would be decelerating. But so do our negatives cancel from our moment?
No, just if there's a deceleration, this kinetic forces will be in this direction. There's no just moment as it is. Just do not just touch. But if this one you find this one negative and also all of your corrections is correct, you do not do any kind of miscalculation, means that, or there's a kind of deceleration, means that this one, this inertial forces is in opposite direction.
I'm just confused for the equation because it says negative WR and then minus WM
Okay.
for the main equation.
Okay, I got it.
So do we just neglect that and then that's
No. Let me just. Okay. Also, these ones are equal, are negative too.
okay.
Yeah. Thank you, Olivia. These are also negative. Minus and minus. This is minus. And also this is minus. Thank you. Yes, these are negative. Now we have the acceleration of the center of the mass. We can find other unknowns. We have the acceleration. If you return back to here, we found the normal force. Now we have the acceleration. We can find the coefficient of the friction. From this, mu multiplied by 1962 equal to 200 multiplied by 8.95. The coefficient of the friction, it will be 0.912. This is the coefficient of the friction and the answer in looking for. Any questions? Any question, guys? No? So far, so good? Let's have 5 minutes break. These are positive. 7.5 plus 7. Yes. There's makeups.
Yes, we just today. Oh.
This one?
Yep, thanks.
Yes.
This is the slide. So, I'm trying to follow what you're doing with the negative WR, WM. And I understand that's there. And then you find numbers on the other side for the moment, like they're not the same. I have WR and then times 9.9. These are the moments. This is the initial force, this is the distance. I get that, but you're plugging the numbers you're finding from this equation into not that. I just multiplied them together. 75 by 0.9. I get that. But what you have up here is negative WR times 0.4. And where the number you're finding from MR times 0.9. And you put that number in, and I don't get how that would make sense. You're finding these two numbers equal to this, which is MR and AGX.
Yes.
MR is 75.
Yeah, no, I get that.
AGX is this. This one is 0.9.
Yeah.
Similar to this one. Then to write this one, I multiply 75 by 94. This is 67.5.
But you're saying, with the part that I'm confused about is you're saying that's equal to WR times 0.4.
Yes.
Where does the 0.4 go in
0.4 is the moment of the weight.
Okay.
This is the moment of the weight of the motorcycle. This is the moment of the weight of the bike. This summation of all of this one is this.
Okay.
Summation of all of this one is that.
Okay.
That helps. I was not following.
I just asked you all later. No, I can't.
Is it good?
Dude, I've been going.
I think mine, she was nice and attempted to drop off the package. He chose to do ones for some reason.
Well, I heard it goes.
I told him to just speak to us because I asked him.
And then when I figured out like 30, maybe the driver doesn't feel like they can. The traffic is all the time that they can't drive. If you open the parking lot, I try to semi walk around in this punch around. He only excuse. She's the inside. I might not be fun to try to talk stuff around in the parking lot, but I can. I also heard that grants. What do you mean? I know, I'm really excited.
That's why they show the wall.
I saw a video. Just getting bigger area. Really did never know that. It's small. I was there yeah, one of my buddies is there.
Yeah, I read this. You read it? No.
Oh, yes.
I've never read it.
Yeah, I'm not going to go exactly that.
We're also watching Miami University.
Yeah.
This is a fucking show.
Well, you like to be here?
Oh my gosh.
Thanks. Any questions? Maybe you review your notes and the solution. Question comes to your mind. Any questions? No? Okay. Now, one part, hopefully I can finish this until 3:05. Then we will start the quiz, okay? Let me know if I pass 3:05. Whatever you learned in previous slides and also previous lecture, you learn about the equation of the motion. For the rigid body has a translational motion. How about that a rigid body has a only rotation? You will see that the equations will be similar. There is a little difference that I will explain. Then I will solve one more example. Then we will go to quiz number 3. Now, there are some applications that the rigid body is only a rotational body. As you can see, this oil pump rig, this Sharpie impact machine, and also this tire testing equipment. As you can see, all of this ones, there's a pin that this one is rotating, or this Sharpie impact. We bring this one up, hold it, then release it, then impact this specimen, and we measure the energy absorbed during the impact, and also this tire testing equipment. They would put the tire, rotate it, and measure the velocity, measure the acceleration for different conditions. For example, you will see that they can change the surface. Also, they can apply forces to apply a kind of the bump force and any type of response. This is also an interesting equipment. Therefore, this type of the rigid body, how we can use the equation of the motion, I will show you. This is a rigid body, as you can see, similar to what you learned in previous one for a translational motion. This one it has a rotation about the fixed axis. For example, this one is rotating about the point O. This is the kind of general rigid body. These are the external forces. This rigid body rotates with the angular acceleration and velocity of alpha and omega. There are external moments of m1 and m2. Now, the only difference in here, you will see that these equations that I showed to you, they are similar with the equations I used it for the rotation of the body for a translational motion. But there's a little bit difference. What is the difference? For a rotation of the rigid body only, I use a normal and tangential coordinate system instead of XY coordinate system. If you remember also, for using a normal and tangential coordinate system, if I track the position of the G during the time, G will move along this curve. Okay? Consider just adding 1 point, 1 circle, then rotate this one. You will see this is a part of the curve. Now for this curve that the G moves, we will introduce tangential and normal direction. How? Just for review. This is the tangential direction. This one is moving this direction. Tangential is parallel to this. This one is the normal. Now for this rigid body, also, you learn that there is one acceleration along the tangential, I call AGT. Also, there is an acceleration along the normal called AG normal. This is for the point G. This is in tangential direction. This is in normal direction. Also, you learn it how to find their acceleration. That was easy. You learn that this acceleration is alpha r, this acceleration is omega r. Omega square r. Now, what is the distance or what is the r? R is the distance between G and O. Okay? This is the distance. Means that here, instead of the r, we will put RG. This is the distance from G to O. Means that this will be alpha RG, or this one is omega square RG. Now, use the equation of the motion. You learn it before. MAGX, sigma Fy. I solve several examples. Sigma mg equal to Ig alpha. These are the equations for the translational motion. Now, if I just use, instead of x, I put t. Instead of y, I put normal force. This equation also will be similar to this. Also here, we have the acceleration on t. We have acceleration on the normal. That I just substitute acceleration about the g, rg alpha, acceleration about the normal, rg omega squared. Or just this is the only difference. That's it. For a rotation of the rigid body, we use a normal and tangential coordinate system because it's much easier to use XYZ coordinate system. And we use the acceleration of normal and tangential as you learn it. And they are dependent to the omega and alpha, angular acceleration and angular velocity. Now, for a rotation of the rigid body, as you learn it, sometimes we do not want to find the moments about the G. As you saw in the motorcycle example, I found the moments about the B, the rear tire, or about the A, the front tire. How about that if I want to find the moment about another point or another point that is different from the G for a rotating body? What we should do? For this one, for example, there's a tire. This is the center of the mass for the tire. Now I do not want to find the moments about the G. I want to find, for example, a moment about A or O. This moment of this point that is contacting with the surface. Why? You learn it. For example, at this one, there are these forces. By finding the moment about this point, I will eliminate some of the unknown forces. For a rotating of the body, if I want to find about any other point that is different from the G, this is the only difference. That sigma mg, it will just convert to the sigma mo or other points, A, B, C, D. Now, right-hand side, it is equal to Ig alpha. Right-hand side of this one, it's equal to IO alpha, or IA alpha, or IB alpha. Then, how we can find the IO? You learn it from the parallel axis theorem. If you remember, I just mentioned that if there is a body that is rotating about the center of the mass, and we want to find the mass moment of the inertia about other points, we can write IO is equal to IG plus the mass of the rigid body, then their distance. For example, their distance is RG. It is RG squared. This is the only difference. You can find the IO from this equation and substitute into this equation and use the third equation as it is. Now, there are some procedure for solving the equations, for solving this type of problem. First, you establish the coordinate system normal tangential as you learn, and also I saw you to draw acceleration in normal and tangential. Also, we will draw free body diagram and the kinetic diagrams. Free body diagram and the kinetic diagram. Then we need to find the mass moment of the inertia. If you want to find the moment about the G, is IG, is already given. If we want to find the IO, IO will be equal to IG plus mRG squared. Then there are three equations of the motion. Summation of the forces along tangential equal to m AGT. Summation of the forces along normal is m AG normal. And summation of the moment about the G equal to IG alpha, or summation of the moment about the O, any other point, is equal to IO alpha. Then there are unknowns we will find. If there are more unknowns, we use the kinematic equations. These are the procedure for the analysis of a rotating body, such as tire. For example, tire is rotating on a kind of slope, or there's a kind of motorcycle or a car that the tire rotates. Also, we can consider the rotation of the tire. Now, examples always is a good choice to understand the concept. This is a basic example. there is a rod with the mass of 20 kilograms. It is rotating with the angular acceleration of the 5 radian per second at the instant shown. The moment of 60 Newton meter, it is applied. Then we are looking for the angular acceleration and the reaction of the rod as this rod, it is in the horizontal position. You will see that this rod is an example for a rotation of the rigid body. This rod is just rotating. Let's write this one. I will start to solve. Okay. Now there's a rod. The mass it is given 20 kilogram. It is rotating with the angular acceleration of the angular velocity of 5 radian per second. This moment it is applied at the kind of this point. This is the moment. This is the external moment. 60 Newton meter. What we are looking for to find the angular acceleration, and also at the pin O, what are the reaction forces? For example, these are the reaction forces. O, I will show. I'm looking for this reaction forces at point O. As you can see, this is a rotating rigid body. Now for this one, we can use these equations. First, we establish the coordinate system. What coordinate system we want to select? This is the center of the mass for the rod. At the middle of the rod, distance from the O, it is 1.5, and also from the tip of the rod, it is 1.5 meter. Then, because this one is rotating, if you follow the path of the G during the time, it will be on this curve. Means that this will be the tangential direction. This will be the normal direction. Now, for this one, we will draw. We already set up the coordinate system. Then I will draw a free body diagram and kinetic diagram. Then I will use this equation, summation of the forces along tangential equal to MAGT, or it is equal to MRG alpha, or summation of the forces along normal equal to MAG normal, or MRG omega squared. The last one is the summation of the moments about the O equal to IO alpha. The reason I selected O because I have two unknown, and by selecting the O, I can cancel these forces. These are three equations I need to solve. Now, first, I will draw the free body diagram. How? Just bringing this one. On this, I will draw a free body diagram. On this, I will draw the kinetic diagram. As you can see, just this one. There is a weight, there is a this point about the tangential, this is the reaction at the normal direction. And also, for this is the kinetic diagram. This is MAG along tangential. This will be MAG along the normal. And also, this is IG alpha. Now for this problem, as you can see, we have this, and also we have this one for the kinetic diagram. Now, first equation, summation of the forces along T equal to MAGT, or MRG alpha. RG is the distance between the G and center of the rotation. This is RG. This is G. About the tangential direction, we have two forces, this and this force, weight and this. It is this direction, it is the positive direction of the T. This direction is a positive direction of normal. This moments I just consider as a positive. Now, weight minus OT equal to MRG alpha. Weight of this one, it is 20 multiplied 9.81 minus the reaction force of the O along tangential direction, this one, equal to mass 20. RG, it is half of this 3, it is 1.5. Alpha that we are looking for. This is one equation. Equation number 1. Any question until now? Okay. Move to the next one. Just bring the equations here and here. I just bring it them here. Second equation, summation of the forces along the normal equal to M AG along the normal or equal to M RG omega squared. Along the normal, we have only this force, ON, equal to mass 20, RG 1.5, sorry. Multiplied by omega. Omega also is given 5 squared. From this, I can find the ON, the pin force at the O along the normal. If you calculate this one, ON will be 750 Newton. This is the second equation, or equation number 2. Now, third equation, summation of the moment about the O equal to IO of left-hand side, just the moments of the forces about the O. These two they cancel because these are at the O, there are no moments. The only moment we have, the moment of the weight about the O. It is weight multiplied by distance. It is weight multiplied by 1.5 plus, what should I add? 60, I heard something. Yes, I should add 60 because there are some external moments. This is the moment. You do not need to add distance such as L. Do not do. This is a moment. Now, equal to IO. How we can find IO? Because this one is different from center of the mass. This is equal to IG plus M RG squared. This is from parallel axis theorem. Multiply by alpha. We have the weight 20 multiply 9.81 multiplied by 1.5 plus 60 equal to, how we can find the IG? IG for the rod, it is 1/12 ml squared. Let me check if this is correct. Yes. It is 1/12, the mass of the rod, 20, the length of the rod, 3 squared. If you calculate this one, 180 divided by 12, this is 15. What's the unit of this one? It is kilogram meter squared. This one is equal to 15 plus mass 20. RG is this distance, 1.5 square. Multiply by alpha. Then we can find the alpha. If you calculate it, alpha can be found. Alpha for this problem, it will be 5.9 radian per second squared. This is one answer I am looking for. Also, this one. The only thing that is unknown here, this one. Now we need to calculate the reaction force in the O along tangential direction. Any question until now? Any questions? Yes.
Can you go back to equation 1?
Sure. I want to. Thank you. Now, from this equation, we already have the O. We want to solve the OT. If you put into this equation, 20 multiplied 9.81 minus OT equal to 30. Alpha also we found it is 5.9. Then OT can be found. Let me calculate. 30 multiplied 9 and minus OT will be 19.2 Newton. This is another answer. Any questions? No questions? Nothing? Okay. Now I want to finish the lecture. I want to ask you just distribute in the class persons who are sitting on the chair on the one tables. Just distribute in the class. Put everything, not everything. You can use your notes, okay? But you cannot use the extra problem I put it in the blackboard. I just put extra problem in the blackboard. So you cannot use that. But you can use your note if you solve the homeworks. You can use them. Yes? Yeah, you can use the equations, but not the extra problems. Okay? I will distribute the question. There's one question. You can scan, upload your answer in the blackboard. The paper is for you. You have 20 minutes to answer the question. Make sure you draw a free body diagram and a kinetic diagram for that problem, and you can go. Yes? I told that. Do you have a charger? You can put in charger in 20 minutes.
I think this should be okay. He did say the largest extreme, the first example is very similar to
If your phone doesn't charge, I will scan and send to your email.
Jason, I ran him down. I actually threw him over the wall, and then he disappeared. If you're creating this creature,
Okay, guys. Any question before we start? No? Two of you, just can you distribute it here? One of you, just. You can use my tape. Thank you. Make sure you do your work. Do not look at your neighbor. I will check it. Thank you. I know you will help me. Okay? Can we start? It's 3:05. You have until 3:25 to upload your answer. I will create it in the week 10. You need to upload it in the week 10. Then after 3:25, it will disappear. Write your name. Paper is for you. I will distribute your exam to grades. Make sure do not look at them after the quiz looked up. You already have your grade. Everybody has a question. Stop. Have a great weekend.